drive shaft. Drive shaft to this lesson. What is the purpose or the main purpose of the shaft? Or the function of the shaft? You do not know. Shafts are there to transmit power. Shafts are there to transmit power. You have a shaft. And then here you have a motor. This side is connected to the wheels. So this shaft is going to transmit power from the motor engine to the wheels. So along, in between the two, there are other components, like gearbox, like two shafts connected. Maybe this shaft is connected to the other shaft so that it can be able to provide a bending. But all in all, when the motor rotates, this motor is going to rotate the shaft. Then the shaft rotates the wheel. So, in that case, the shaft will be transmitting power. So, the power transmitted by this shaft, the power which will be transmitted, it will be 2 pi nt over 60. That will be the power that will be transmitted by the shaft. SI unit, watt. So N, it's a speed for the shaft in rev per minute. It's rev per minute. If you are given it in rev per second, it means you do not need to divide by 60. You get the part? You divide by 60 because this is rev per minute. The shaft which is connected to the motor, it has the same speed as the motor. If the motor rotates at 10 rev per minute, as well as this one will rotate at the same speed. You get the part, right? Yes. So the T is a top. That's a T mean. That's a mean torque. The transmitted torque. The torque that will be transmitted by the shaft. That is T mean. We have T mean. I can say T average, T mean, the transmitted torque. We also have what? T max. T max is the maximum torque the shaft can take. The maximum torque the shaft can take. Meaning For you to get this one, you need to know the properties of the shaft. At what shear stress will the shaft fail? So, okay, the relationship between the two. Remember, you are transmitting this torque, and the shaft can take this one, and the shaft is connected to the motor. The motor that is transmitting the power, and the shaft can take up to that much, cannot take more than this one. So how is these two connected? These two, Tmax is equals to over load times Tmin. The Tmax is equals to overload times Tmin. This torque, as I indicated, is the torque transmitted. This torque is the torque which the shaft can take. So, when we talk about overload, let's take for instance, we have overload of 20%. What is it that we are going to substitute there? Sorry? 80%. Another side. There's an overload of 20%. Sorry? 1,2. Yes, you are going to substitute here 1,2. 20% is the same as 20 over 100. Do you agree, right? Which gives us 0,2. But this is an overload. You cannot have an overload before you have a full load. Meaning you need to have a full load, then you have an overload. So in that case, you are having 100%. That's a full load. And then, after having a full load, you add together with the overload. Does it make sense? So in this case, 100% is the same as 100 over 100 plus 20 over 100, which this is 1 plus 0.2, which will give us 1.2. You understand, eh? So every time for overload, if you are given 30%, you need to first put 1 for full load, then after, then it's a percentage overload. You get that right now? So what will you substitute if we have 5% overload? What will you substitute here at overload? Sorry? 1,05. You will substitute 1,05. So let us, for example, we have the overload of 15%. The overload is 15%. 15% overload, and the mean torque is equal to 50 kilonewton meter. In this case, what will be our maximum torque? What will be our maximum torque? What do you get?
57.
1.15 times 50, you get what? 57. 57,5 kilonewton meter. So this one, it will be your maximum torque. Is the maximum torque which your shaft can take. Meaning in this case, the shaft cannot take more than that one. So what if there is no overload? What if there is no overload? If there is no overload, Tmax is equal to what? Tmin. Yes. If there is no overload, Tmax is equal to Tmin. So that is the function of the shaft, or the purpose of the shaft. To transmit power. So we have T over J is equals to shear stress over R is equals to G theta over L. That is a very important formula for this chapter. What does T stand for in this formula? What does T stand for? So what? We have two torques. T stands for the torque. We have the mean torque and the Tmax. It's for Tmax, right? This T is Tmax. So, the T being Tmax, I said this Tmax is the torque which a shaft can handle, right? Yes. That is the torque which the shaft can handle. So, and we have two types of the shaft. We have two types of the shaft. So which shaft are we talking about if we have two types of the shafts? Which shaft are we talking about? We have solid and also a hollow shaft. Meaning for you to know the Tmax, you need to know which shaft are you talking about. Because the shaft which is is transmitting the power, it can be hollow, it can be solid. So which one are you talking about? So let us check under a solid. When a shaft is solid, what will be the value? How will you calculate Tmax? When the shaft is solid, how will you calculate Tmax? Is pi over 16 d cubed times shear stress under solid. While solid shaft it only has one diameter. This is a solid shaft here. This is a solid shaft there with only one diameter. So Tmax for hollow shaft, it will be pi over 16 into d to the power 4 minus d to the power 4 shear stress all over d. So for hollow shaft, a hollow shaft, it has a hole. So this will be our hollow shaft. That is the hollow shaft, which it has the outside diameter as capital letter D and the inside diameter as small letter d. So this is how you calculate your Tmax for a hollow shaft. And make no mistake, this d is d to the power 4 minus d to the power 4, outside minus inside. The moment you take this to the power 4 and you put it outside the brackets, it's wrong. You get the wrong value. You cannot do this. D minus d to the power 4. This is wrong. Do not do that. So later on, you need to divide by what? Outside diameter. So, if you were to go and buy a shaft, it means you need to know the power the shaft can transmit or the torque the shaft can transmit, and as well as will I buy solid or will I buy hollow shaft? You get a partner? So, you tell me here, if for instance you are having a truck and your truck is using pro shaft, right? And your pro shaft currently is using a solid shaft. You go buy at the space. Your truck is too old. They are no longer manufacturing the pro shaft for your truck. And when you get there, they said, we have the same, but this one is hollow. Instead of having a solid, we have a hollow. What is it that you will check? Beside fittings, you'll check if the hollow shaft can transmit the same torque as the solid shaft. Because if you do not check that, it will transmit the same torque. Therefore, this shaft, the new shaft, it will keep on failing. You get a partner? Yes. So, in another way, if you are told to replace a solid shaft by a hollow shaft, what are they trying to tell you? They are trying to tell you that the Tmax for solid is equal to Tmax for what? For hollow. When they say replace a solid shaft by a hollow shaft, they are saying T solid is equal to T hollow, which means now we can say T solid is pi d cube over 16 is equal to pi over 16 d to the power 4 minus d to the power 4 shear stress all over d. Meaning this pi and pi cancel, 16 and 16 cancel. You get that part, ne? Yes. When do you apply this one? Sorry? When they told you to replace a solid shaft by a hollow shaft, right? Yes. If they say replace a solid shaft by a hollow shaft, they are actually telling you to do this. So, and when they say, I don't know, you are replacing, So now they say the two shafts, they are made of the same material. If they say the two shafts are made of the same material, they are trying to tell you that consider the shear stress being the same. You get a point? If they say the shafts are made of the same material, they are trying to say consider the two shafts, the two material being the same. Consider the shear stress being the same. You understand that part, right? You guys understand? Okay. So now, we also have, we're talking about the T, which says the T-max, which is differ for hollow and for solid. Now, let us check at the J. What does J stand for? Sorry? Polar moment of inertia. Polar moment of inertia. So same applies. For solid, polar moment of inertia, it will be pi d to the power 4 over 32. For solid, no, for hollow, it will be pi over 32 into d to the power 4 minus d to the power 4. I repeat again, do not take this 4 outside the bracket. Polar moment of inertia. So meaning when you are told to calculate polar moment of inertia, you must be aware what is which type of the shaft is connected. Until you know the type of the shaft, you won't be able to know which formula between the two to use. If they say a solid shaft, blah, 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 they are saying consider this formula, these formulas. If they say a hollow shaft, blah, 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 they are saying consider those formulas. So, this is a tau. This is a tau, which represents the shear stress, right? Yes. And the shear stress depends on the material you are using. Meaning you'll be given or you'll be told to calculate. If you are told to calculate, it will depend from the other ones. So the next one is R. What is R? What is R? You don't know what is R? Answer it, yes. For solid shaft, how do you get R? For solid shaft, how do you get R? Is D over 2. Then for a hollow shaft, how do you get R? For a hollow shaft, how do you get R? Outside diameter minus inside diameter over 2. In a hollow shaft, they were having a hollow shaft, a cross-sectional area of a hollow shaft. This from there to there is an inside diameter D, from there to there is an outside diameter D. So on a hollow shaft, you're supposed to use a mean diameter. or a mean radius. The radius which is between the two diameters, which is the distance from here, from the center up until there. If you are having the outside diameter and you are having the inside diameter, how to get that distance there? Is capital letter D minus small letter D
over 2, all over 2.
all over 2. When you take the bigger one, you subtract the smaller one, you divide it by 2. Which distance do you get? Which distance do you get? You took this one, you subtracted this one, right? When you take this one, you subtract this one, you left this distance and this distance, right? When you divide it by 2, you only left with this distance, right? Yes. And we are looking for distance from there to there. Meaning, for you to get this smaller distance, can you see this smaller distance? You need to take this again and divide it by 2. So in that case, you left with the distance from there to there. Which after that, you will need to add it with this smaller radius, which is the same as smaller d over 2. So you take this one, it is the same as having capital letter D minus D is this one. You divide this again by 2. It will be divided by 4. Then you come and subtract small letter d. You add, All in all, you're gonna left with, after simplifying there, you are going to left with capital letter D plus inside diameter all over 4. That is how you calculate your mean radius. This radius, you did not get it from the smaller radius, you did not get it from the outside radius. It's a mean, the one in the middle. The one in the middle, the mean diameter. If you're having this shaft with the hollow there, the one in the middle, if you were to come and cut here, then you open. As you open, the shaft, what will happen? The inner diameter will stretch. The outer diameter will compress. But the middle diameter remain neutral or remain the same. Hence, we use that one. So G in the formula is the modulus of rigidity, which will be given depending on the material. And the theta. Theta is an angle of twist in radians, not degrees, radians. So now, how to calculate angle of twist? To calculate angle of twist for a solid shaft, it will be 10.2 Tmax times L all over G d to the power 4. For this one, T.2 Tmax times L all over G into d to the power 4 minus I to the power 4 in radians. So after you have calculated in radians, if you want to convert to degrees, you know how to do so. Mathematics syllabus. So the L is for the length of the shaft. L is for the length of the shaft. So if you have noticed, every formula, when it talks about T, it refers to maximum torque. Is the only one formula that uses mean torque, which is a power. The one we started with, power. Power is equal to 2 pi nt over 60. It's only this torque, which is the mean torque. The other torque, as we talk, is the maximum. You get that partly? Yes. But remember, we said if there is no overload, the Tmax is equal to the Tmin. Okay. Now you know the two types of the shaft. You know the two types of the shaft. You know how to calculate the torque on the different shaft, column moment of inertia, how to find the radius, how to find the angle of twist. We were talking about a shaft. One shaft, which can transmit power. So now, let us check. If now you have a motor, your motor is connected to the shaft 1, and your motor is also connected to shaft 2. You have another motor. This motor is connected to the shaft 1, and the shaft 1 is connected to the shaft 2. Is either by the use of the gear drives, or by the use of the belt drive. Do you get that one? Yes, you have learned about gears and the belt drive or mechanic. So this is gear shaft 2, this is shaft 3. Let us first look on the first connection A. The connection A, this is connection B. The motor is there to provide power, right? To provide us with torque. And we know that the torque, the ref for this one is the same as for that one, right? So, revolution for this, and revolution for this one, and revolution for that one, they're the same. The number of 10 that they see. If this one 10 once, even this one's going to 10 once. So the first one, just ignore the motor and concentrate at the two shafts, shaft number 1 and shaft number 2. What kind of the connection is that one? It's a series connection. Eh? So what we have been talking about here, this one, it was for the types of the shaft, solid and hollow. Now those shafts, they are connected in series. If they are connected in series, what is it that you need to know? If the two shafts connected in series, what is it that we need to know? Series connection, what is it that you need to know? Series connection. Under series connection, you need to know that the torque which is transmitted by this motor is the same torque which is transmitted there. Is the same torque which is transmitted there. So that will mean if you can calculate Tmax for this shaft, the same value, it goes there. Do you understand the part, me? Yes. Shaft 1, it can be any of the two. It can be either solid, it can either be hollow. So if shaft 1 is a solid, you'll use this information. If shaft 1 is a hollow, you'll use that information. But what you need to know, the torque for shaft 1 is the same as the torque for shaft 2. It's the same torque as the motor. Because these they are connected in series. So T1 is equal to T2 is equal to T3 is equal to T total. The torque in a shaft 1, it must be the same as the torque in the shaft 2. It must be the same as torque on the motor. I'm saying T total referring to the motor. Because the motor is the one that produces all the torque. What type of the shaft is this one? Solid, how do you know? It will depend on the given information. It's either they connect a solid and the hollow, or a hollow and the solid, or a solid and the solid with different dimensions. You get that part, me? Yes. So let us now go to, before we go to one, before we get to the second connection, the angle of twist is the opposite of this one. This one, they will equal, it means this side, you will add them. To get the total, you add them in series. So now let us come to parallel. Number B. At number B, what type of connection is shaft 1 and 2? Parallel. What type of connection is shaft 2 and 3? Series. So meaning, in this case, the torque of the motor is equal to the torque on the shaft, right? But the torque on the shaft 1 is not the same as the torque on the shaft 2. Because these two are connected in parallel. So should it happen that you manage to calculate the torque on shaft 2, now you know shaft 2 is connected in series with what? Yes. Let's say here there are gears. You will calculate the torque for this one, right? Yes, using the motor information. You calculate the torque for this shaft. From here to here, you will need to use ratios. When Meccano, they taught you about ratios. Speed 1 over speed 2 times the ratio, T1, T2. You remember those things. So if you manage to calculate the torque here, using ratios, you can calculate the torque there. And once you get the torque for this one, you already have the torque there. You get it, partner? Yes. Is there any question? Is there any question?
Yes, how do you calculate
Sorry?
the total?
Come again?
How do you calculate the total on a parallel connection?
On a parallel connection, parallel. Parallel is the opposite of the other one. So how do you think you need to calculate the total torque?
C1 is equal to T total is equal to T1.
Yes. Yes. T total is equal to T1 plus T2. And what about angle of the twist? They are equal, right? Yes. So lastly, in here, if you are given the information of this one, make sure that you calculate torque using this one. For instance, let's take this shaft is a solid, this one is a hard. For you to calculate the torque here, you need to use the same diameter and the same shear stress of this. Or if you are given power, you will need to use the speed for this. You understood, ne? I was saying, for you to calculate torque, in most questions, you'll give them the information of the power of the motor. They will say the motor has this type of the speed of the power, and it rotates at a certain speed. Meaning you use this two. The torque which you are going to get is for this shaft. Then you will use the ratios to calculate the torque for this shaft. If you are given the ratio. You get a part, me? Okay. So that was all.